Hello, here is Team Serial Killers. Now we are going to present our findings about the offensive language in social media. Here are our contents in this presentation. Our presentation contains 5 parts. These parts are based on the cross-industry standard process for data mining, which is a famous methodology for data analysis. Firstly, we will introduce business understanding. It includes business objectives, data mining objectives, and success criteria. There are 3 business objectives. The offensive language should be identified, the offense types should be categorized, and the offense target should also be identified. Our data mining objective is just to build a model, and the success criteria is to check the F1 value, which is a measure of a test's accuracy. It considers both the precision and the recall of the test. Next is the data understanding. The data is provided on the website and we download from the website directly. The dataset includes training set, test set, and label. There are 13,240 entries with 5 attributes: ID, tweet, subtask A, subtask B, and subtask C, such as shown in the figure. There is no duplicates and no missing values. Also, the CSV files should be converted to ARFA files when using Weka. We expected the ARFA files can be identified by Weka. Our data preparation contains 3 parts. First is data filter and linkage. We divide the training set into 3 subsets, which are used for the 3 tasks. Next, we link the test set and label set of each task by the key of ID. Then we do some transformation in tweets. We convert single quote into back quote, emoji into English words using Python module emoji, strange letters into normal letters, which can be all correctly recognized by Weka. In task A, we remove all @user and hashtag, where we believe these 2 strings are useless in classifying whether it is offensive. However, these strings can help classifying the task B and task C. And then we change the Weka setting. We add brackets and braces into delimiters and set stammer as iterated loving stammer to do stemming, and a stop words handler as rainbow to make the sentence stop in a more sensible way. The classifiers we choose to use is J48, random forest, and naive Bayes. For J48, we refine the model through changing the value of reduced error pruning, and for random forest, we change the value of num-iteration. For test option, we use training set firstly to find a good model, and then use applied test set to re-evaluate the model. The performance of every model is shown in the table. For task A, the best classifier is random forest with 150 iterations. The figure for F1 value is the highest. We do not choose naive Bayes since it has lowest accuracy. As for J48, it probably results in overfitting. The detailed summary is on the right. For task B, the result is a naive Bayes. In the table, some results are presented as question marks because it is single classification, which is a big problem. F1 value cannot be calculated. When we apply random forest, F1 value is high for training set, but it's low for test set. So we finally choose naive Bayes with highest F1 value for the best classifier. The detailed summary is on the right. For task C, random forest with 10 iterations is the best choice. When we add iterations to 20, F1 value for training set increases, but F1 for test set decreases. It is overfitting, so we choose the model with the highest F1 value for training set. The detailed summary is on the right. Before we start our model building, we click on the bottom More Options and choose Output as CSV. Then click on the CSV and set the path of the CSV. Then we can get the output CSV file after we build our model, which is shown in the figure. Thank you for listening.